Welcome back. After finishing the quiz, let's have a look into patching these if instructions. We are now pretty familiar with how they work, but how can we patch them to modify the application behavior to get into the other branches or things like this? Generally speaking, there are a lot of methods. I will introduce 3 of them because I guess, with those 3 you will solve all your tasks you want to do. Alright, let's dive into the first one. Method 1 is logic flipping. Sounds promising, let's see how it works. Okay, on the right side we've got our Java code and on the left we've got the corresponding Smali code. And let's have a look into this. We are creating a new player object over here. Then the player gets hit. So in the last exercise we lose a player life over here. But now there's something different. The player has now a new instance field named shield. You got a feeling what we are going to do in the next couple of videos? Yes, absolutely. So in this case our player has now a new instance field shield. And if the player has now a shield and the player gets hit, the player doesn't lose a life, the shield gets removed. So player.shield is now equals false and we move on in our code. And in case we do not have a shield, so if player.shield is false, then the player loses 1 life and we also move on in our code. Alright? Okay, let's have a look at the Smali code. So in this line we are having v1 initialized with 0x1. And then we've got an iGetBoolean, so we're getting this instance player.shield, which is from type boolean, into v2. And now we've got an if statement. And this if statement is, please read it out loud, if v2 is equals 0, then jump to condition 0. So it looks like this. Now we need to step back and think about this. Let's see what we are checking. Okay, we are checking if we are having a shield. The shield is from type boolean. This means the shield can be true or false. If we are now doing a comparison against 0, it means we are checking if the player does not have a shield. Because if the shield is 0, then it's false. And this is the comparison against 0. So this statement would have been or would be true. Alright, so this is our statement if we do not have a shield. Then we jump to condition 0. Let's see. Condition 0 is over here. We are fetching our player.lives into v2. We are subtracting 1 from this. We are putting it back and then we return out of this. Alright, this looks good. Otherwise, let's have a look. So if we are having a shield, it means it's not equals 0. Then we can see v1 is initialized with 0 and we're putting our shield state to 0, which means our player.shield is now false. So we lose our shield, but we do not lose a life in this approach. Okay, and then we jump to go to 0, which is here, and we return out. Alright, this looks okay for me. Now let's see how we can patch this code that we get an advantage out of this. So there are many different approaches we can do. In my case, I want to talk about flipping the logic, which means if we are not having a shield, we do not get hit. And if we are having a shield, we do get hit. Alright, how can we do this? With only 1 instruction over there. Think about the if statements and all these different types. Can we use this to change the behavior? Absolutely correct, we can do this. And we do this with the following sign. We are adding this exclamation mark, and by doing this we will flip the logic. Our if equals 0 will become if not equals 0. And let's do this approach once again. How does it look like? So still we've got a 1 within our register v1. Now we are putting our player.shield into v2. We are not having a shield right now, so this statement or v2 is holding the value false. Now we've got, this becomes now a little bit of a brain task, so it's getting a little bit complicated, but let's see. Let's do this once again. If v2, which is false, is not equal 0, we jump to condition 0. Alright, once again. If v2 is not equal 0, we jump to condition 0. Okay, this means if our v0 is not equal 0, we jump to condition 0. So in our case, v2 is not true. v2 is false. Therefore, we do not jump to condition 0. Okay, then we move on over here. We are putting 0 into V1, and then we are putting false back again into our player shield state. And this is ridiculous because this means we still keep our player shield on, because we have flipped the logic. By having player shield equals false, we cannot get hit. And this is good because, we are putting this value here once again into this. Therefore, it does not get overwritten. Therefore, we are having still our shield, or imaginary shield over here. But it will protect us, so that's good. Okay, and afterwards we go out of this. So flipping a logic makes it really complicated. Therefore, we have to say it out loud and think about what we want to check and what we did. Normally, if you understood the initial if statement and you want to have the opposite of this, you can simply flip this by not even thinking about this. By thinking about this, you might get a little bit confused afterwards, but you will figure out it's still correct. So that's what we've got right here. And this is something we want to code right now and then analyze back again, because it's really complicated, I know, but we practice this. That's why you're here. And together we will make this, and afterwards you can do a lot of funny things. We will learn some other methods, which might be sometimes a little bit easier, but for now let's stick to this one. Okay, before we code it, let's do it once again together. Let's do it for the initial state. If v2 is equal 0, we jump to our condition 0. This means we are not having a player shield. Now we patch this instruction with the exclamation mark, and therefore we switch the equal 0 to not equal 0, which means unless we are not having a player shield, we do not lose a life. It's also for me not easy to do this, so I have to think about this. But by thinking about, we get the solution. Okay? Alright. Now let's get back to our Ubuntu VM and code this real quick. Okay, here we are at our Ubuntu VM and we still got this old project open. Let's see. Yes, we've got the check high score and we've got this get hit over here. Alright, let's write this piece of code to implement that we've gotten shield. So we are having a new instance field, boolean shield. And let's set this to true, because then we start with a shield, and if we get hit, we shouldn't lose a life. Afterwards, we remove the shield, and if we get hit once again, then we lose a life. Alrighty, so let's see. We are now in our get hit method. So if this.shield is equals true, we do not get hit. Otherwise, which is in this else over here, we do get hit. Okay, after getting hit and having a shield, we need to remove the shield because the shield blocked this collision. So this shield is equals false. And here we can also see an additional patch possibility, which comes handy for us. Let's say we are not removing our shield. So let's say this one stays true. This would mean that if we pick up once a shield, it does not get removed. So it stays there forever until we end the game. This would be also a nice patch, but with a little bit of a downside. We have to pick up the shield first. And this is something we do not want to do. We are super lazy and we want to start with all we want to have. Therefore, it's a nice patch, but not what we are looking for. Alright, so this one is set to false. Afterwards, we get hit. Okay, and that's our code. Let's try this out. So we click on build. And I'm also making the ADB connection to our VM. Already connected, that's good. And locate, there we go. And let's install this app. A screen copy, there we go. Smali 2. This is our application. Let's see. So we are now having a shield. This means if we get hit or if we press the button, we get hit, but we have our shield. Therefore, we should not lose a life. There should be in 5 afterwards, 5 lives. Let's see. We get hit in 3, 2, 1, now. All right, nice, it's working. We have now lost our shield. We can check this by hitting this button once again. Yes, now it's reducing the lives. All right, let's do a quick check if it's really correct. So let's close this one over here. Okay, and now let's remove this shield. We build it once again. Okay, locate, adb install app debug. We are opening it. Okay, if we now get hit, we do not have a shield, therefore we should lose a life and there should be a 4. Let's see. 3, 2, 1. Yes. Okay, I'm glad that this worked. Otherwise I had to figure out what goes wrong. But this is exactly what we want to have. All right. Regarding to the state, this doesn't really matter because the state changes in the game over and over again. We take a look at this over here, at this if statement and how to patch this. So I'm going to decompile this application and then we pull out our graphic tablet. And so before we decompile this application, I really would like to add something. So this is not an Android development course and the things I have shown so far are perfectly fine to create simple mockup apps to test or train a special topic like if conditions. However, these applications might not look that fancy, or let's say they are a little bit boring. And therefore I have also provided a more fancy version of this application over here. The code is pretty identical, so the only difference is that the Smali 2 design version has an additional button to pick up a shield and some form of visual output. You can do exactly the same in the mockup application with some sort of debug statements, for example system out print line. This is also perfectly fine. So to patch this application, to start with the shield, I recommend using the Smali 2 design version or to set the shield state to false in our mockup version. I also provide you all 3 applications in this section as an attachment. In the Smali 2 design version, you have some sort of visual output. In the Smali 2 no shield version, you shouldn't lose a life after patching it. It doesn't matter in which version you apply the patch. All that matters is that we understand how flipping the logic affects our application and that we can achieve what we want in there. Because later on we will take our approach to real-world applications, for example, to bypass the routing detection or to modify our SpacePing application to achieve certain features. Alrighty? Perfect. Okay, let's reverse this real quick and then we figure out how we can patch this to, get and shield permanent. Okay, this time I also try to write this a little bit more clean, that it doesn't get that messy, but I'm not sure how good this goes. So let's see. All right, we've got our method over here, get hit. So here we have our method name. We can see 0 parameters, okay, and return void. This is our function prototype. Okay, then we've got iGet and we have our this object over here. So P0 is this. iGet means we've got an instance field. So we've got this and here's our instance field, this.shield. And this is being put into V0. Okay, so V0 is now this.shield. Okay. Then we are having V1 is being initialized with 0 and we are having V2 is also being initialized with V2. By the way, I skipped about this, but we are already familiar with this. So I guess I do not have to explain regarding to the local 3 anymore. You might be bored about this one and I can fully understand this. Okay, so back on track, we are within V1. V1 is now 0 and V2 is now 1. Okay, then we have our if statement. So we stick to this dramatic color over here. And let's read this out loud together. If v0 is not equal v2. If v0 is not equal v2. Then we jump to this condition, and this condition is here. So we jump to this one over here. Okay, let's check what this if is about. v0 is our this.shield. So if this.shield. Okay, my promise, I guess it's already over. So let's see. If shield, okay, is not equal and v2 is true. Oops, there we go. Okay, this is our if statement. So if this shield is not equal true. Sounds a little bit strange, but we will figure out what this is about. Let's see, then we get into this one. We are fetching p0, this once is our this back again, this dot lives, and we are fetching this value and putting it into v0. So v0, oh, that's interesting. Let's change the color. v0 is this dot lives. So why is it interesting? Because we are overwriting v0 at this point over here. So here v0 is referenced to this dot shield, but now it's being overwritten to this dot lives. So take care, overwritten. And yeah, if we keep track on those registers in this way, we do not have any trouble. Therefore, we know, okay, v0 is now this dot lives. Okay. So we are at this line over here. Then we are subtracting v0 equals v0 minus v2. So we are subtracting v2 from v0 and storing the result back in v0. Okay. v0 is now v0 minus v2, which is v0 is now this dot lives. This dot lives subtracted with 1, yes, this one over here, minus 1. Okay, and then yeah, we are putting this value back again, and you can see those patterns. You have seen this in the past, and you will see this also in some other examples. And by practicing Smali, you immediately identify those patterns. So we are getting this value, we are subtracting 1, and then we are putting it back again. This is simply just the subtraction from one of this instance field. Okay, this means this dot lives, which is now p0, okay. So this dot lives, or let's change the color for this, because we are not having v0 in this case, we are having p0 is equals v0. p.0.lives to be more correct. Okay, so this dot lives is now equals v0. All right, we just subtract 1 from this dot lives and put it now back again into this one. Okay, then we have another if statement, this one over here. So let's see. Okay, if v0 is less equals 0, we jump to this condition. So if v0 is less equal 0, we jump to this condition. And this condition is over here. Okay, let's recap this. What is v0? v0 is our this.lives, as I can see it from here. Yes, v0 has been referenced last at this line over here. So this was the last time we have referenced or initialized v0. It's not initialized, assigned a value to v0. This means this is our this.lives. This.lives. Okay, if this.lives is less than equals 0. Yes, this means we are about to losing the game. Okay, so let's see. Then we are putting v1 into this one over here, p0. And this is now, p0 is our this object. So this, and here we have our instance field, this.state. Okay. This.state is now we are putting v1 into this. v1 is 0. 0. Okay. But we are putting a boolean into this. This means we are not having 0. Yes, we are having 0, but in this case we are having false. So this.state is false afterwards. Okay. Then we have our goto, but this is not our goto instruction. This is just our goto label, which can be ignored. And then we are simply returning out of this function. So return afterwards. All right, and that's it. So now we've got the true statement for this case over here. Now we need to do the same for the false statement. Therefore, we are having our else. And yeah, I hope it's not that long, but let's figure out. First, I want to clean this up real quick. There we go. All right. Okay. So we've got this condition, so we are not jumping right now, we are moving on at this part. Now we are putting v0 into p0. This is once again our instance field. This dot also state, okay. So this dot state is now v2. Oh, I realized there, I'm not sure why I didn't write it in this way. Normally I do not do this. So let's clean this real up. Yeah, I'm not sure why I did write the 0 in there. That's not what I like to do because we lose track of the registers. And yeah, sorry for this, but now we are back on track. We've got I put v2 into this dot state. Okay, we are at this line, yes. And v2 is now true. This makes sense. So now we're putting true into our this.state. And then we've got this goto label and also the goto instruction, which is even more important because now we know we jump to this goto underneath. And then we are returning out. Okay. So that's it for the else statement over here. Now we've got this complete if block. We've got both. Let's do it here. So we've got both branches. We've got the true and the false branch. We need to repeat this for this one over here. And I hope it's not that large, but I will minimize this a little bit that we can write on this in this clean state here. Okay, we are back. Let's see. We are in this statement over here. We've got this part already. So here we are done, but we need to get back to the false statement over here. And this one is this part underneath. So this is our if statement. And now we've got the else, which is the false part. Okay, regarding to the false part, we move on right here. Let's see. We are putting v1 into p0. So again, this is our this object. And it's this dot shield. All right. So this dot shield, I hope the space is enough. Let's see. Is now equals v1. Let's see what is v1. v1 is false. Nice. False. All right. Okay, nice. Then we've got our go-to label, and this go-to label we can see here. Yes. So we are jumping right down here, and then we are simply returning out of this function. Okay, that's good. So we are done. Okay, so this is our code. It fit to this page, which I'm very happy about this. So let's see what this code does and how we get an advantage out of this. Let's recap this first. So we've got our player object over here. This is our player. And this player doesn't start with a shield. If we get hit by a shot, for example, we lose a life. So if this one hits us, we lose a life. Okay, and if we are picking up a coin, so yeah, we didn't write the code regarding to the coin, but this is when the player shield state changes, at least for the space ping application. So we have our space ping, and now we are fetching this coin. Then we get our player shield around us. All right. And if we now get hit, we do not lose a life, but we lose our shield afterwards. Okay, let's see where we can find this part in our if statement on the right. So we start over here. We are looking for the point where we are losing lives and where we change the shield state. So is it within this or this if statement? Let's see. This one over here. We are having here this one. This is the initial first one, this one over here. And here we can see, okay, that's it. We already found this. Because in this if statement, we make the decision. If we lose a life, which is this one over here, this line, or if we change the player shield, which is this line over here. So we even do not have to look it up in this if statement here. So this one can be simply ignored from our side right now. All right. Now let's check this if statement. So let's do this. v0 is our this dot shield. Okay. So we are having our player, and this player has now a shield. So if this dot shield is not equal v2, v2 is true, and we write this down in the exact same way. We write this down as if our shield is not equal true. Then we go into this condition. Okay, this condition is, let's check this once again. Where do we have it? There. Okay, this was this one. Okay, and this is this part over here. All right. It's a little bit hard regarding to thinking about this, and also the brain is a little bit confused. But if we keep doing this, you get practice and then you will be faster on this. So let's check this out. What do we have here? If our shield is not equals true, this means we are not having a shield. This is what this statement is about. We are losing a life. This line over here. And that's absolutely correct. Yes? If we do it differently, no, I guess that's too confusing. Let's just go in the false statement. Do not try to flip this right now. So if our shield is not equals true, so we are having no shield, we go into this part. Otherwise, we go into this part. One line beneath this if statement. Okay, and this line is doing this part over here. So this line is doing this part over here. So it's resetting or setting the shield to false. Okay, so we got our statement and what's doing, and yeah, we know everything about this right now, even if it's a little bit confusing. Now it's getting a little bit more confused, but think of what I have recommended. So in this case, our player has no shield. If the player has no shield and get hit, it loses a life. Now we want to change it. We want to change it that our player has a shield. And if we get hit, we do not lose a life. And to get this state, we can simply flip this if statement. This will lead to, if the player on the left, this is the original statement, picks up a shield. So let's do it this way. The player will be protected. So this is this part over here, regarding to the correct statement. In our case, it would mean if we are picking up a shield, we are not having any shield anymore and we are vulnerable. So as long as we are not picking up a shield, we are safe. But I guess it's even a little bit complicated right now. So just stick to the recommendation. If you want the opposite case, so starting with a shield, this one over here, we want to start with a shield and lose 0 lives if we get hit. Then we have to flip this logic over here. This means instead of not equal, we are having equal. But still, let's think about this. Let's go through this if statement and see if it's correct. Therefore, we clean this up on this side over here. So we have flipped the logic. This means we should now have the case that our player starts with a shield until the player picks up another one. But that's not important. So this would be our case. Our player starts with a shield. Let's see. Okay. If v0 is this dot shield. If this dot shield is equals true. Okay, so we are changing this to this statement. If shield is equals true. Then we go into this instruction or this branch over here, which means we are losing a life. Yes. Okay, that's bad. But let's take a look at the other side of this coin. So this one here becomes now false. So we are not having a shield. Is equals true. This is of course not the case. So this will be false at an outcome, this if statement. This means we go into this line over here. And this means we are ending up here. All right, this is confusing, I know. Try to think about this once again, maybe twice or 3 times. It's really hard, but by keep practicing this, you will be doing this in a few seconds for the next sections. Okay? So let's check this once again. If we are now not having a shield, we cannot get hit, or no, let's say if we are not having a shield, so our player starts the game and the player does not have a shield. If the player does not have a shield, we get into this branch over here. And this means our shield will be false. All right, but this also means we are not losing a life because we are not getting into this branch over here. And let's see how this goes. Okay, so we start our game, we are not having a shield. If we are not having a shield, we end up at this branch over here. So if we get hit, we lose our shield. All right, let's get back. If we get hit, let's see, our shield is still on the state false. This means we are still having no shield. This means if false equals true, we end up here. Okay, but regarding to the flipping the logic, it's super hard for, at least for my brain, to follow this. And if you also struggle, write it down in this way. Maybe a little bit more clean than I do, but yeah, if you write this down and if you keep saying it loud, it will help you a lot. Okay. All right, so let's practice this real quick. And so first, let's get our connection to our device. Okay. So let's get the screen and then let's install this application over here. And this time I'm using the Smali 2 design version, but as already mentioned, it works exactly the same with the other one, the Smali 2 version. But this has a more, fancy output. So we are installing this app. All right, and then we have a quick look into this one. We can see we've got a very nice icon over here. And if you open this, nice, this looks absolutely beautiful. So we have our lives, and if we click on hit, then we can see we lose a life, and if we get a shield, then we can see we have a shield over here. If we get hit once again, then we lose our shield. And we have also track about this one over here. So if we now get hit, we are not having a shield, we are losing a life. That easy. 2 lives left, let's get back a shield. We are immune for 1 shot. All right, perfect. Let's decode this application and then apply our patch. So we are using the APK tool D. And now we are opening the Smali directory once again with Visual Studio Code. So Smali classes 2. And this time not only this time, I always trusted author, but this time we are having a little bit of a diversity regarding to the line numbers. So if we go into app hacking and then into player.smali and let's enable Java. And then if we scroll down, we can see this line number is now 38 and before it has been 37. The code is exactly the same. So every instruction over here is the same, but the line numbers are different. Nevertheless, we do not care about line numbers, we just care about those code lines over here. Therefore, we can simply ignore them and within our application, so if we have a look into our application with JDX GUI, then they perfectly match once again. So do not get distracted by different line numbers, focus on your application, on your state, and then you're good to go. Alrighty, so over here we've got our condition, if not equal, and now we are flipping the logic. So we have extensively reverse engineered every line in here and now we fully understand this part over here. Which means if we are flipping the logic, then we are flipping the logic regarding to the shield. So now what we should have is, we shouldn't start with a shield, but we should be immune until we pick up a shield. Alrighty? Okay, let's verify this. We apply our logic flipping, not equal becomes equal, and now we are building back this application. We've got it still here. So APK tool B, Smali 2 design. All right. And now let's sign this application. And first we need to zip align it. So this is now Smali 2 design. Then we need our APK signer to sign this application. Change it as the password. And now we need to uninstall the current version. Let's do this real quick. Oh, not this one over here, it's this one. All right, and now let's install our version, out APK. Get back the screen and then let's see if our patch has been successful. So we start this application and now let's see. If we can see shield is false, so everything looks normal until we press the hit button. We can see we are not losing any life, which is super amazing, right? So we have now flipped the logic that we are having a shield, and based on our infinited loop, we are not changing the state. So we do not lose any life because our shield state doesn't change anymore And yeah, based on the logic flipping, we are now immune for this application until we pick up a shield. So if we are now picking up a shield, we can see visually wonderful output, and we can also see a shield has been set to true. If we now click the hit button, then we can see our shield stays active, but we are losing lives. So this is exactly what we have expected, and this is how flipping the logic works. We have flipped the logic of this application, and yeah, we get a huge advantage out of this until we pick up a shield. Alrighty? In the next one, we take a look at the method 2 and then method 3, and then we have tons of exercises where you can practice all these things. Okay? So I'm looking forward to see you there.